Hi everyone and welcome to the channel, and today we're going to be looking at an assembly first approach for creating a box with components within, such as this. So when we say about assembly first approach, we're looking at creating the electronic parts first, so these electronic components, as a footprint for any cutouts or hollows in the box to take these components. Once these are created, we can build the box after they've been assembled. So here I have the electronic components assembled in the right configuration, and then a box is created around those. This is just a simple box to get the idea across, and you notice that we've got these cutouts here. The good thing about this workflow is I can move the parts under constraint, such as this potentiometer, and hit OK, and the box automatically reconfigures and adjusts around those components. So for instance, let's take the port, right click and transform, and bring this down and hit OK, and you can see how that readjusts. We've also included configuration tables. So for this part here, this potentiometer, I've actually built it so these can be adjusted. So if I click on potentiometer, I have a drop down here that I can adjust the size of, and the same with the breadboard. This will also have an effect on the assembly when we hit refresh parts in the A2 Plus workbench. So I hope you're enjoying these videos, and let's have a look how we would follow an assembly first approach. If you like what you see and you want to donate to the channel, then you can do so via Ko-Fi or Ko-fi at ko-fi.com/MANG0, or via PayPal at paypal.com/paypalme/DarrenBEstone. I also run a Patreon where you can get early access and additional content, and that's at patreon.com/MangoJellySolutions. Links can be found in the channel header, on the About page, or in the descriptions of these videos. So the idea is to create a number of components that we arrange, and then we create an assembly out of those, and then create the box around the assembly. Hence the reason assembly first. First of all, let's get our components done. So we're going to use the part design workbench and create a new body and a new sketch. And let's go on the XY plane. So the first component I'm going to create is a potentiometer. I'm just going to quickly rough one out. So we'll create something like a base in here, something like this. And this is not an exact model. This is just the footprint of the model. So we know how much it's going to take up in our case and what cutouts we need, if any. So let's make those two equal. And we'll set some distance on here. So length of 20 mil. Okay, that one. Let's close that and pad that by 10 mil. These will be all in the spreadsheet in the end. And then we can add something on top of here. Sketch with a circle, something like this. And it's just for the footprint. So I'm going to place another diameter on here of 10 millimeters. Close that, and we'll pad that to 30 mil. So we've got something very simple like this. So that's one body. And we'll just call that pot part for the potentiometer. And I'm going to come over to the spreadsheet. So come into the spreadsheet workbench. And we'll set up a spreadsheet for different sizes. So let's come in and create a spreadsheet in here. And we'll add some sizes in here. So across the top, I'm going to put in what it's for. So this is for the potentiometer, just call it pot. And we'll place it in here, type, and base size, and the knob diameter. And these have to be strings. So this is going to be a lookup where we can change the size of that potentiometer. So we leave this one blank, and there's a reason for leaving this blank. There are tutorials about configuration tables on my channel. You'll be able to pick up the process from those. So I'm going to quickly go through this. And these have to be strings. So we're going to put in here a P1 and a P2 just for the time. We can add more in here if we wanted to. Base size, 20mm for this one. And this one's going to be a bit bigger. So let's put 30 for this one. The knob diameter, this one can be 10 and this one can be 15. So what were the diameters on this one? So that was 10, yes. So we're there. So that allows us to create some proper diameters with the actual part itself. So that's changed that sketch. So we've got a sketch in here and this is the knob diameter. So we come in here and we're going to change this one. Now the thing is, with my spreadsheet I've got here, let's close that. I want to be able to select each of these. So I'm going to make something called configuration table. And what I do is come up and highlight these from this blank row here. And if I right click and configure table, so I've encapsulated all the data included in the blank row at the top, it allows me to set up the configuration table with a cell range, starting from the blank row, the last cell of data, which is C5. Let's go for C5. And then I'm going to attach the configuration table to the body. So we type in body, which is this one here, the pot part. I can even come in here and use the pot part, which allows me to attach it to that one there. That makes it more descriptive. And we need to add some kind of identifier in here. So I'm going to go for config. This can be whatever you want. I'm going to call it config. Or let's call it pot types. And OK that. So what we've got now, if I come over to this pot part here, we look down, we've got pot types, and we can change this to whatever one we want. Now, if we notice that the spreadsheet has got this row in here, and it's copied the value of the first one into that. If we look at the pot part, we've got the pot types, and if I change this to pot type 2, look at the spreadsheet, this has changed. So now I can alias up this row, and we've got base size. I'm just going to use the same column names here. So we've got base size, and this one, you can see it's highlighted in yellow. That's going to be the knob diameter, NOB dia. So we've got those there. Now let's go back to the sketch. Let's close that. So I'm in that pad in this sketch, and we'll alias up this diameter here. We'll come into this brushing, the formulas, and what we'll do is hit delete and type in spreadsheet. And we want the alias, which was knob diameter. There we go, and OK that. You can see we've got 15 grayed out in there. Hit OK. This has changed to orange, which means it's referenced outside of the sketch, and we can close that. So we've got that one in there. Let's do this one now, which is the pad. It's actually at the top. We want the base, this sketch here. Let's double click that and set up the base. Double click, and we want this one, spreadsheet, and type in base size. So we've got spreadsheet.base size, and OK that. OK that again, and close. So now we've got all those sketches linked to that spreadsheet, which is controlled by the pot part, the body. So this drop down here, when I change this now, our configuration table kicks in, and we can change the sizes of this. Let's make another component. So back to the part design, we're going to create a new body, and we're going to create a new sketch along the XY plane. And OK. Let's come over to the model and just hide the original pot part, this one here, press the space bar, and we'll create a breadboard. Remember, this is just a footprint, so I'm going to create a rectangle and use these two edges and this center point. Symmetrical constraint, you can use a center to a rectangle if you want, this one here, and set the sizes. And again, we're going to control this, get some sizes in for the time being, control this via spreadsheet. 60 by 70 for the breadboard. Just rename the body, right click, rename, and type in breadboard. Let's go to the spreadsheet and create another configuration table in here. So this one's going to be, say at this point, if I'm going to add more in here, it might be best to come over to say here and type in breadboard and place them in here. So you can have more than one configuration table in a spreadsheet. Again, type, and let's place height, width, and length. Again, leave this row clear and type in here, I'm going to go for a B1 and a B2. You can call these what you want. So the height here will be the actual thickness of the breadboard. Maybe I should type thickness. So this one will be, let's go for something like 10 with a width of 60 and a length of 50. And we'll just make a smaller one in here of 30 and 25. Do we have the same thickness? And let's go for slightly smaller, so something like 8 mil on the thickness. So we've got this one set up. Again, highlight these rows, right click, and configuration table. So we've got E3 to H5, so H5. Let's place H5 in there. And the property, I'm going to place it on the body. Use the name, so we need the breadboard there, so we get the right body. And we'll change this one to config as well. You can call this whatever you want. And then hit OK. So we've got the config on the breadboard, and this is the config on the pot part. Let's say this is up. This one is going to be BB thickness. And this one's going to be BB width. And this one's going to be BB length. So we've got our sketch in here. And we'll set this length spreadsheet dot BB, and we'll put this as the width. Okay, that, and okay. And this one, double click that and set that as BB. Well, it's actually going to be spreadsheet dot BB length, and okay. So we've got those two in there. This creates our breadboard, just the footprint of the breadboard. Let's go over the tasks and hit close. We'll take that sketch, we'll pad this, and we'll set the parameter in here to spreadsheet dot BB thickness, and okay that. So now what we've got on the breadboard, we should have a config which we can change, which will change the size of the breadboard. So now we've got our part set up. So we've got a breadboard and a potentiometer. Let's save this and can call it electronic parts. And we'll quickly do one more. And we'll create a body, create a sketch, XY plane, okay. And this is going to be a part that doesn't change size. So we've got our body here. Let's get hold of the breadboard, press the space bar to hide it. And something very simple like a port or something like that. We'll do that. We'll put some length in here of 30. This height of 20. We've got that there. Close that. Take that sketch. And it's going to be some kind of board. So I'm going to pad it by 2 millimeters. And then on top, we'll add a sketch. So I've selected that face. Add a sketch. And we'll place something in here. So let's bring in this line, which we're going to attach it to. Let's zoom in a bit so we can see what we're doing. And I'm going to place just something quickly on here, like so. And this will have a height of 12 millimeters. And we'll place it some distance away from here. So I'm just doing this one very quickly of 4 mil. And we can set some length in here as well of 4 mil as well. So we've got something very simple. I'm just going to pad that. So select that sketch and pad that by 3 millimeters. And what we've got is basically something like a port. So this is going to be a port that we can push a connector into. I'm going to right click and rename that to port. So it's a port on a board. So we've got our footprints of our electronic components, and now we can go about assembling them. So we have all our parts in one file, our electronic parts. We've got the port, the breadboard, and the potentiometer, and we can change them via the drop downs that we've added onto the bodies, or set our port. We're going to create an assembly for these now to place them into a position and then create a box around them. So we're using an assembly first approach. And to do that, we're going to be using the A2 Plus workbench, this one here. If you haven't got the A2 Plus workbench, just come up to Tools and Add-on Manager. And you'll find it within here. And we can check for updates and see if that actually needs updating. I've checked for updates and I've got an update available, so I can click on that and click the update button, which is close, and I'm going to restart now. So I'm back in FreeCAD and I can come over to the A2 Plus workbench, and I'm going to create an assembly in here. For that, I'm going to create a new file and then straight away save it. So File, Save. And I could call it Enclosure Assembly. We've already got the electronic parts open here, but what I'm going to do is import those parts into the assembly first. So I'm going to use this button here, Add Shapes from External File, and click that. We'll find our electronic parts, and we have each of the shapes here. So we've got the breadboard, the port, and the potentiometer. The first one we import is going to be the fixed part, but we can change that. So I'm just going to check all of them and hit import. So they've come in. The first one that's been laid down is the fixed part. And if I move my mouse, all I need to do is click and we get the next one. And those are all in our assembly. So I've got all the components in our assembly. I'm just going to come up to View and toggle Axis Cross so I get an idea of where my axis is to make this a lot easier. So with assemblies in the A2 Plus, because it has a solver, it needs a fixed part because the solver will solve the assembly through a chain to the last part, which is fixed. So we always need a fixed part. Now, because this one was imported first, we look down, we see this fixed position as true. We can change that. We don't need to have this as a fixed position. We could have the port or the potentiometer as a fixed position, but I'm going to go for the breadboard because it's logically the one that will be the fixed position. And I can move this with a right click and transform. Fixed position parts are moved with the basic right click and transform. The idea here is to get a layout of how the components are going to sit in an imaginary box. So for instance, I want this component here. I've got this port here. Because this is a fixed position now, I can start constraining to this. So if I think of my box is going to come around here and encapsulate all these items, then I would say that this face here would probably be in line with this breadboard. I click one face control click the other, we get the constraints that come up. And we've got a number of different constraints here. We've got planes parallel and we've got planes coincident. So these two faces will be on the same plane if they're pointing in this direction. We make those planes coincident. If we have a plane here and a plane here, these will pull them into a planes coincident. Remember that the plane is not just the face, it's the plane that this face sits on. So if we place an infinite rectangle here, it will be in line with this face. So control click both those faces, they're highlighted, come up and use the plane coincident. And what you'll see is they'll be pulled coincident to each other. Remember the infinite plane that they sit on, and you'll see they are actually in line on that same plane, and we'll just accept the constraint. So now I can actually move this with this tool here. So there's a tool, move the selected part under constraint. So we click that and then click the selected part, this part here that we want to select. If we move it, I can't move it forwards, move it left and right, but I can't move it backwards either. And also I can move it up and down. But we stop and keep that plane that face sits on coincident with the plane of the breadboard, that face there. So I'm going to place this. Now I'm thinking that if we have this port with some legs on here, then maybe we want to place it on the breadboard. So we want to place it here. So straight away we might see that, well, actually we might need a bigger breadboard, and we can adjust that. So that's there. I'm going to perhaps take this edge and control click this edge and use an axis coincident constraint. So those edges, if I click that, that'll bring those edges together. The axis of those edges, and they'll be coincident, and we'll set that. So now if I try to move this, what will happen is that we move it under constraint. So I can't move it backwards, I can't move it left, I can't move it right. The only way I can move it is up and down now, because it keeps the axis of this edge together and also the faces of these. So they're both coincident to each other. So one thing to note is that we don't need both of these constraints. The first constraint that was added allows us to move along that plane. By adding the axis constraint on the edge, it actually makes the plane's coincident constraint obsolete. Once I'm happy with where this is going to sit, I can then move on to this one. Now it may be handy to come in to the part and right click and transform and get it into the right position. For instance, let's bring it around this way and then hit OK. So that's in a position that we can easily make our additional constraints against. Again, I'm going to use this plane of this face and this plane of this face and make them coincident to each other and accept that. And maybe I want this bottom edge as well. So take that and this edge here and make those axis coincident and accept that. So these are on the same line here. And then it's a case of using the move selected part under constraint, select that part and move it across to wherever we want. So I want to move it, say about here. So this could be my layout totally finished. And this is where I'm going to create the enclosure around. Let's save that. File save or Control S. Now at any time these can change size. Remember we had, if I go back to the electronic parts, remember these can be changed. So the sizing of them, so that's changed this breadboard. If we look at the breadboard, we're on a breadboard 2 at the moment. So let's drop this down and use the breadboard 1, which is a much larger breadboard. We have to save this. So Control S to save, and let's go back to our assembly and we'll refresh, update parts imported into the assembly. Hit that and the breadboard updates, and you can see that the breadboard is updated in size, and we just need to make some finer amendments, finer adjustments with, say, this potentiometer, like so. Now we've got everything in place, we can start building the enclosure. Now it's important to build the enclosure within the assembly itself. Therefore, we get an idea of where all these parts sit, and we can create subshape binders against these parts, against the enclosure, to take out such things as the cutouts or hollows for our parts to sit in. I'm going to be using the part design workbench for this. So remember, we're using the same assembly file. That's come over to the part design. Now we must make sure that nothing is selected in here, otherwise it's going to pull it in as a base feature. If it is selected and we create a body, that's going to come in as a base feature and it's going to take its original position. We don't want that. Let's Control Z that. So we make sure nothing's selected in the model view and create a body. The body has been added. The next thing I'm going to do is Control select a number of edges from the imported components, which will define the boundaries of our box that we can use a subshape binder against and make sketches against that. And we'll take these two as well. Control select these. So I've got those in there. And we'll click on the subshape binder. This will pull those edges in. So now if I hide all of these parts here, what you'll see is 4 orange lines. So now I can come into the body, got the body there, and create a sketch along the XY plane and hit OK. We can see those 4 lines there, so you can see them in the sketch. I'm going to use the external geometry tool and import these lines into my sketch. Remember, the sketch is 2D, so we're going to get the vertices going along here. Let's click on top and have a look, see what we've got. So we've got the vertices that have been pulled in as a reference to that box. So now we can create the box. Now I'm going for a standard box across here. And I'm going to come out this way because I want some clearance for this box. So something like that. Let's hit escape. So this point and this point. And we're going to use the lock constraint. So I'm going to quickly lock those into position. This one will be a minus value, but that's fine. So we're going to give around 5 millimeters of clearance. And the same with this one, 5 millimeters. We can use the horizontal and vertical if you want. It's up to you. But lock is quite useful to actually get this geometry down quite quickly. And a lock constraint on this side. Again, it's going to be 5 millimeters. Clearances, remember this one's -5. Clearances and sizes, etc. can be controlled via a spreadsheet if you want to. And we can place that in a usual single spreadsheet for all the items that we're going to place in here. So we've added all those constraints and let's close that now. So we've got the outline of the box that we want. Let's bring back the elements. I'm going to click on one and press the space bar and then click on the others and bring those back in. So we've got those in there. If I wanted clearance with the sketch, I can take the sketch of that body, come down to the attachment because it's attached. See, the attachment is first, the position, and change the position along the Z axis. And we can give this a clearance of, say, 1 millimeter or so from there. So we've got that part in there now. Now comes the fun part. Let's take that sketch and let's just create a simple pad and bring the pad all the way up so it encloses all the items within, like so. It's totally up to you how you make that enclosure. We may want a half enclosure, for instance, something like this. So it's halfway, but I'm going to go for a full enclosure and then remove the walls in here so I can see inside. That's okay, that. I'm going to take the enclosure and now use a thickness to remove those walls. And I quite like this beveling on the outside. So I'm going to keep that. We don't have to. We can come over to the left and select different join types like intersection, but I'm going to go for arc and we'll increase that slightly to something like that. Remember, we can make this go inwards by using the make it thickness inwards if we wanted to, and go this way. And it's totally up to you. Let's actually do the inwards thickness. So we've got that there. So we've got a 2.2mm. Let's change this to 2. And we'll OK that. We'll say we're just creating this box here. We can actually put a top on here if we wanted to, but we're interested in creating the cutouts of this now. So for the cutouts, we use subshape binders. So let's click on the box and hide it and think about the subshape binders. We have the face here and a face here that we need to use as subshape binders. So we click on this one here, and what will happen if I create a subshape binder for that one, we've now created the area that we need to cut out for this component here. But we need some clearance, because if we cut this out, this is going to be tight on this component and it won't turn. If we look to the left, we have this binder. And if we come down to the offset, down here, we can use an offset here to increase this offset by, say, 2, and click off. And you see we have the offset there that we can cut out from the shape. Let's click on the binder and just reduce that down a bit. We've got 2 here. Let's reduce this down to 1. So we've got some clearance now. We can go 0.5, etc. Now what I want to do is pocket this through the thickness. So our last operation, this one here. To do that, let's just hide the component by clicking on it and pressing the spacebar and select the binder. We use the pocket. And what we'll see is that because we've got the length, it's pocketing, but it's not going far enough. If we chose through all, it will go through the wall and outside the other, which is not what we want. And if we go up to face, what we can do is pick the face this will travel up to. So I'm going to come round inside and select the inside face. And we've pocketed through one face and up to the back face. So right through that material there. Let's hit OK. And turn our attention to the next component. So I'm going to click on the box and just press the space bar to hide it. Come in, select the face I want to pocket, this one here, and use the subshape binder. Because we've got an active body, it'll pull that face within. And again, we can click on the binder, come down to the offset, and give it an offset, say of 1mm. Let's have a look what that's going to look like. Might be a bit too much. Let's go for 0.5. We've got arcs set for the offset type. We can use that as intersection or tangent if we wanted to. Let's go for arcs to make it look nicer. Now we've got that subshape binder. Let's hide this component and bring back the pocket. So our last action, the tip, press the spacebar. Click on the subshape binder and use a pocket. Now you see that it looks like this has disappeared, but what's happened is that the model has shifted to the left. And we need to use this item here, the fit all, to bring it back into view. Let's zoom in. We've already got the subshape binder selected and the operation is being applied, but we need to click reversed. So it goes in the reverse direction. And from here, we can select up to face. Let's see if this is going to work, and click on this face and it will go through and out the other side. Or we could just use the dimension as you saw before, and that would actually work with that one there. If I click OK, what we have now is the box with the cutouts. So I'll bring back the parts. You can see that we've got the knob of the variable resistor, the potentiometer in there, and we've got a cutout for the pull. These subshape binders are relative to the object that they've bound. You can see that on the binder. If we go down to the binder here, you can see that we have the relative, if I can find it, is set to true, which means if we go back to our assembly, the A2 Plus assembly, and let's hide the binder and any binders that we see in there, we've still got the pocket there, and we use the move the selected part under constraint and select, say, this one here and move it over and drop it there. You can see it hasn't updated as of yet. So we need to force an update. If I go out to edit and refresh, you can see it's not available. So FreeCAD hasn't seen that it's been updated. We can force a simple update by right-clicking and transform and just moving it slightly and hitting OK. And that will force an update for the box to actually update and everything is back in position. The same with just right-click and transform. If I put this right out here and hit OK, it forces everything to update. So this means that I can place these parts into positions that I want. Let's bring this up a bit. And the subshape binder underneath will follow, as long as I force an update. Now, if I didn't use right-click transform, I could come into the binder. So this binder here is binder 2. And right-click on the binder and use synchronize. You see a tick has been placed upon the binder, and using the shortcut key for refresh, or just edit refresh, that will move. So you can see that's moved as we've moved the component. We can move that under constraint and just use the transform, right click, transform, just give it a small nudge and hit OK. And it's moved there. Or we could transform this, move it under constraint, and then come over to the part, this one here, look at the placement and change the position slightly. And that will update. So we've got full control over our model just by moving these parts. For our enclosure to update. So I hope you enjoyed that video, and I hope to see you in the new one. If you like what you see and you want to donate to the channel, then you can do so via Ko-Fi or Ko-Fi at ko-fi.com/MANG0, or via PayPal at paypal.com/paypalme/Darren B. E. I also run a Patreon where you can get early access and additional content, and that's at patreon.com/Mango Jelly Solutions. Links can be found in the channel header, on the About page, or in the descriptions of these videos. I thank everybody that's donated so far. It really helps to keep the lights on so I can produce more content and also expand the channel. Thank you for liking, commenting and subscribing to these videos, and I hope to see you again in the next one.